Hello everyone, today we're going to be going over section 3 from the SAT practice test number 3. We're going to be starting off with question number 1, which asks us, a painter will paint n walls with the same size and shape in a building using a specific brand of paint. The painter's fee can be calculated by the expression n times k times l times h, where n is the number of walls, key detail, k is a constant with units of dollars per square foot, L is the length of each wall, and H is the height of each wall. If the customer asks the painter to use a more expensive brand of paint, which of the factors in the expression would change? Well, the answer off the bat is going to be K, because K is the only unit here that actually has dollars in it, right? K is the only thing that really pertains to price. K is a constant whose unit is dollars per square foot, right? So if I'm making something more expensive, I'm going to change the variable that has the dollar sign in it, obviously. H and L simply don't make sense because if I'm asking someone to use a more expensive brand of paint, what does it matter? Like, why does it matter how high or how long the length and width of my wall that I'm asking them to paint? That's not going to change if I ask them to use a more expensive brand of paint. I'm not going to make a new wall. I'm not going to shrink or make my wall bigger, obviously. And I'm not going to tell them, and the number of walls that I ask them to paint isn't going to change, right? The only thing that changes when I want to use a more expensive brand of paint is the unit or the factor that has dollars or that relates to price. K is the only thing that relates to price, so it's the only correct choice. If we move on to number 2, it says if 3r is equal to 18, what's the value of 6r plus 3? Here we're given 3r is equal to 18. We can solve for r. If we divide by 3 on both sides, we get r is equal to 6. And now we can plug this value of r into this function, this expression right here, right? So we have 6r, which is the same thing as saying 6 times 6 plus 3. Right, PEMDAS multiply first, so we're left with 36 plus 3, which is going to equal to 39. So choice D. Moving on to number 3, it says which of the following is equal to a to the power of 2, 3 for all values of a. If you don't know this rule about exponents, whenever you raise something to a fraction, the numerator of that fraction is what you're raising this number to, and the your denominator is going to be the degree of the root. Right? So for example, if I have a to the power of 2 over 1, that means that I'm raising a to the second power, right, over the square root of 1, or like root 1, which is just a, right? Since a 2 over 1 simplifies into 2, the same thing as saying a to the power a squared, right? Same thing when I have a to the power of 1/3, that means I have a to the power of 1, right? So just a, and then the power of my root is going to be 3, so it's the cube root of a. Right? So this is the same thing as saying 1 root a, which is just a. So now I can combine both those details together, and I know that because this is the power that I'm raising a to the power of 2 over 3 is equal to a squared, and then this is the power of the root, so 3 root, or cube root, right? And that's going to be choice D. Moving on to number 4, it says that the number of states that joined the United States between 1776 and 1849 is twice the number of states that joined between 1850 and 1900, right? So here I have these two time periods. If 30 states joined the United States between 1776 and 1849, so I know that 30 states joined here, and X states joined between 1850 and 1900, which of the following equations is true? So before I do anything, I know that the amount of states in this time period, right, between 1776 and 1849 is twice the amount in 1850 and 1900, right? So if this is double this, and this is x, this is the same thing as saying 2x, right? If x represents the states that joined in 1850, and I know that the states that joined in 1776 is twice that, that's just 2 times x, obviously. And here, I know that 30 states joined in 1776 to 1849, so I have 2x is equal to 30, right? So x is 15. Right? And this makes sense, right? If I have 15 here and this is double that value, I have 30 because 15 times 2 is 30. And here we go. Choice B is going to be the right answer here, because it's asking us which of the following equations is true. We solved x to be 15. 2 times 15, it is 30. That's all. So moving on to number 5, it says if 5 over x is equal to 15 plus x plus 20, what is the value of x over 5? So all we have to do here is just cross multiply, solve for x, and then divide it by 5. So 5 over x is equal to 15 over x plus 20. I'm going to cross multiply. I'm going to multiply 5 times x plus 20, right? So 5 times x plus 20. And now I'm going to multiply x by 15. So this is equal to 15 times x, which is 15x. I'm going to expand this. 5 times x is equal to 5x plus 5 times 20, which is 100. And this is equal to 15x, right? I'm going to subtract by 5x on both sides. and I'm going to be left with 100 is equal to 10x. I'm going to divide by 10 on both sides. I know that 10 is equal to x, but it doesn't stop there. Remember, it's asking us for x over 5, right? So if I know that x is 10, 10 divided by 5 is equal to 2, which is choice C. Moving on to number 7, it says the function of f is defined by a polynomial. Some values of x and f of x are shown in the table above. Which of the following must be a factor of f of x, right? Whenever you're dealing with a factor of a function, that factor has to represent a 0 of the function. What I mean by this is that the factor has to show you in some way that whenever that x value is plugged into the function, the function is equal to 0. So for example, if I have this function here, and if it passes through the points -5 and 5, and I have this quadratic, I have this polynomial, right? I have this polynomial right here, right? My factors obviously are going to be x plus 5 and x minus 5, right? Because these are my factors. How do I know it? Because they show me when the value of the function is 0, or when the y value is 0. X plus 5 shows me that when x is equal to 5, right, y is equal to 0, and x plus 5 shows me that when x is -5, it's equal to 0, which is this point. And x minus 5 shows me that when x is equal to 5, y is equal to 0, because 5 minus 5 is 0, and -5 plus 5 is also 0. So what I'm trying to say is that factors show you the x value, or they show you the x value that makes the whole function equal to 0. That's all I'm trying to say here. And it's going to be a lot more clear. If we look at this table, we know that when x is 4, this function is equal to 0, right? Because when we have an x input of 4, the y is 0. So that means that 4 is a 0, right? Now, which one of these expressions shows that 4 as making the whole function 0? That's going to equal, or that's going to be choice C, x minus 4, because 4 minus 4 is 0. That has to be a factor because it shows us, right, a value of x that makes the function 0. 4 minus 4 is 0. So it's showing us that 4 is a 0, which we confirmed in the table above. Moving on to number 6, it says, if x comma y is a solution to the system of equations above, what is the value of x minus y, right? So I'm going to rewrite it down here. And whenever I'm dealing with one of these system of equation problems, especially on the no calculator section, I'm always going to try to look for a shortcut, right? I'm going to try to find a way so that I don't actually have to solve this brute force, put something in terms of 3x, put something in terms of x. I'm not going to do that. What I see here is I see that if I add this function, right, I saw a shortcut, right? When I was writing this down, I noticed a shortcut. And that shortcut is if I add these two expressions together, or these two equations together, 2x plus 3x is 5x, and -3y plus -2y is -5y, right? -14 plus -6 is -20, right? I'm left with 5x minus 5y is equal to 20, right? The important thing is I saw that if I added these two x values and I added these two y values, I get 5 as my coefficient, right? And now what I can do, now that I have 5x minus 5y, is I can divide both sides by 5. And I'm left with, these two cancel out, this cancels out. I'm left with x minus y is actually equal to -4, right? So rather than setting something in terms of one another, right, I found a way to make both of these values the same and then to divide by that value just to get them alone, right? And the answer, of course, is choice C. So moving on to number 8, it says the line y is equal to kx plus 4, where k is a constant, is graphed in the xy plane. If the line contains the point c comma d, where c is not equal to 0 and d is not equal to 0, what is the slope of that line in terms of c and d? So what this is telling us is it's giving us the equation of the line. Now what this k is our slope, right? They're calling it a coefficient. Sorry, they're calling it a constant, but really, guys, it's their slope. And it's asking us what the slope is, right? So if I just said k is our slope, I'm going to have to rewrite this in terms of k, right? So I'm going to have to solve for k, right? On this, really, these expressions are the same thing, are just telling me k equals, right? If I want to rewrite this in terms of k, I'm going to have to move some terms around. But you may be asking me, like, why is there only c and d in the answer choices? And that's because we're told that it passes through a point c comma d. And the only thing that means is that when x is equal to this value, d is equal to this value. So really, I could rewrite this as d, as my y, is equal to our slope times c, which is acting in as x, plus 4, right? And remember, you can do this with any line. As long as you're given a point, you can plug that in. Just remember to plug in this value as a y value and this value as an x value. Now that I'm dealing with terms that are the same terms found in my solutions, right, or my answer choices, I can do that thing that I was talking about. I can solve for k, right? So in order to solve for k, I'm going to subtract 4 on both sides, right, because I want to isolate it. So here I have d minus 4 is equal to kc, right, or k times c. Now I want k on its own, so I'm going to divide both sides by c, right? These two are going to cancel out, and I'm left with k is equal to d minus 4 divided by c, which is answer choice A, right? All I did here was I figured out that I need the slope, right? And I just solved in terms of k, which is our slope. I identified that k is our slope. That's all. Remember that whenever you're given something in the form of y equals, the thing that's multiplying your x is going to be your slope. So moving on to number 9, it says, in the system of equations above, k is constant and x and y are variables. For what value of k will the system of equations have no solution, right? So when it's saying constant, it means it doesn't change. That's all, right? And here we're given 2 lines, pretty much. In a system of equation, we're usually given 2 lines, right? And a solution for a system of equations is usually when those 2 lines intersect. So for example, the lines I just drew, the solution is going to be the point or the points at which those 2 lines have to intersect, right? Because guess what? At that specific point, those 2 lines are equal to each other. They're equal to the same amount of points, right? So that's considered a solution. Here, it's asking us, what value of k does the system of equation have no solutions? So when a system of equation has no solutions, it's often representing parallel lines, right? If a solution is a point of intersection, then something to not have any solutions means it never intersects at all. And if you took geometry, you know that lines that are parallel never intersect. So for example, these 2 lines, right? They're parallel. They will never intersect. And because they have no intersection, they don't cross each other, they have no solution. So really what it's asking me is what value of k, or what slope, if I put a slope in here that to act as k, will make both of these lines parallel, right? We know that parallel lines have the same slope, but a different y-intercept. So we're looking for the value of k that mimics the slope of the bottom function right there. So the first thing I'm going to have to do is I'm going to have to write this in terms of y equals mx plus b, because this m gives us our slope. This is the slope-intercept form. This is the easiest way to tell the slope. So here, I'm going to write 4x minus 5y is equal to 7, right? Now I'm going to add 5y on both sides. And I'm left with 4x is equal to 5y plus 7. I'm going to subtract 7 on both sides. And I'm left with 4x minus 7 is equal to 5y. Next, I'm going to divide by 5 on both sides. And I'm left with 4 over 5x minus 7 over 5, right? I just split them up, right? Is equal to y, right? So this is our equation. Now, we're going to do the same thing. We're going to put this in terms of y equals mx plus b, or this in terms of y. So here we have k, I'm going to do this on the side, kx minus 3y is equal to 4, right? So here I have kx is equal to 3y plus 4. Kx minus 4 is equal to 3y. Divide by 3 on both sides. Here I have k over 3x minus 4 over 3 is equal to y. So I'm going to write that down under here. I have k over 3. I'm going to delete this box too because I think it's confusing some people. So here I have k over 3 times x minus 4 over 3 is equal to y. So right here, we know that our y-intercepts are different. So yes, these are parallel. Now, all I need to know is what value of k, when I plug it in there and divide it by 3, gives us 4 over 5, right? So, in other words, right, k divided by 3 has to equal to 4 over 5, right? So now I can just cross multiply again because I have two fractions equal to one another. So 5 times k is 5k, and now 3 times 4 is 12, so 5k is equal to 12. K is equal to 12 over 5, because if I divide by 5 on both sides, right? So when k is equal to 12 over 5, this now becomes 4 over 5, and they have the same slope, different y-intercept, and they become parallel, which means they have no solutions, right? And I could prove that to you if I have 12 over 5 and I divide it by 3 over 1, right? Remember, cube change flip, so you actually flip them when you multiply them, right? So that's 12 over 5 times 1 over 3, which is 12 over 15, which is the same thing as saying 4 over 5 when you divide it by 3, right? And now that the slope is the same slope, they are parallel. So moving on to number 10, it says, in the xy plane, the parabola with the equation y is equal to x minus 11 squared intersects the line with the equation y equals 25 at 2 points, A and B. What is the length of AB? So what's happening here is I have this parabola, right? I know that because I have an x squared function. And I also have this function y equals. When I have y equals 25, now whenever I have a y equals and I have no x to be found, that means that this line is straight, right? It's just a flat line, flat horizontal line, right? And it's telling me that when I have this function and this function graphed at the same time, they intersect at 2 points, right? So here and here they intersect. Now they're asking us what the distance between those 2 points of intersection are. So remember in the last problem, I said that the intersection is the solution, or that intersection was when those two graphs are equal to one another, right? They're equal at this point. And the way to solve for that, or to solve for that point of intersection, is to set those two graphs equal to one another, right? They're both in terms of y, which is good. And they both share the same y value here. So all we have to do is just set them equal to one another. So here I have x minus 11 squared is equal to 25. I could I could expand that. I have x squared minus 22x plus 121 is equal to 25. Now I'm going to subtract 25 on both sides. I'm left with x squared minus 22x plus 96 is equal to 0, right? And now all I have to do is FOIL this, right? I can FOIL this into, well, what multiplies into 96 and adds to 22. That's going to be x squared. That's going to be 16 and 6, I think, right? So x minus 6x minus 16x, right? 16 minus 6 is negative 22, so that's good. And negative 6 times negative 16 is 96, so that's correct. So plus 96 is equal to 0. Next, I'm just going to factor out the x. So here I have x minus 6. I'm going to factor out negative 16. Here I have x minus 6. And this is now equal to x minus 16 times x minus 6 is equal to 0, right? And this is going to give us those 2 points of intersection, right? You may be saying, why is it equal to 0? Doesn't matter. The thing is, I started by setting those two equal to one another, and I just solved from there. And because my starting point in this equation was setting them equal to one another, even if it's equal to 0, it still gives us the point of intersection, right? So the thing now, the answer isn't 16 and 6 and negative 6. It's 16 and 6, right? Because 16 minus 16 is 0, and anything times 0 is 0. And here, if x is 6, 6 minus 6 is 0, and anything times 0 is 0. So the point of intersection really is x equals 6 and x equals 16, right? Now, it's asking us the distance between them, right? If this is point A and it's at 6, and this is point B and it's at 16, what's the difference between A and B? Well, in order to get from 6 to 16, you have to add 10. So the length of AB has to be 10. Number 11 says, in the figure above, lines K, L, and M intersect at a point. If x plus y is equal to u plus w, which of the following must be true, right? So here I'm given this diagram, right? It's an x and another line going through it, and I have a bunch of angles. And I'm also given this expression, this equation, x plus y is equal to u plus w. Now, before I do anything, before I look at my answers, I noticed something. I noticed that I have vertical angles. Right? And all that means is that whenever you have like an intersection between two lines, the angles opposite one another are going to be equal to one another. So what that means is in this example where I have this line and this angle and this angle are both going to be equal to one another, the same way that this angle and this angle are going to be equal to one another because they're opposite. So keeping that definition in mind, I know that y and u are equal. So y is equal to u. Sorry about that. Y is equal to u. I know that x is equal to t. I know that w is equal to z. Okay? So perfect. Now what I can do is I could focus on this specific equation, right? And it's telling me that x plus y is equal to u plus w. Now I already know that y is equal to u. If these two are the same, I can subtract y from both sides. And because y is equal to u, really, first off, I could rewrite this as this. X plus y is equal to y plus w, right? Because as we see here, y and u are vertical angles, so they're equal to one another. So I could just substitute y for u because they're the same value, right? And now I could subtract y from both sides, and I'm left with x is equal to w, right? Now, if x is equal to w, and w is equal to z, right? Cut the middleman, and that means that x has to equal to z, right? Does that make sense? Because it's like associative property or whatever, some stupid property math, but really think about it, right? If x is equal to w and w equals to z, I could just replace w with z. The same way that I replaced u, I could just substitute z for w. The same way that I substituted u for y. And here, that's choice number 1. So I know that choice number 1 is correct, right? That x does equal z. Perfect. Now, I'm going to look at choice number 2, right? It's saying that y is equal to w. Now, is y really equal to w? I don't think so, right? Because think about it. We already know everything that y can be equal to. Y can only be equal to u, right? There's no transitive property, there's no associative property, or any magic that we can really do with this, right? Y and w aren't even on the same part of this of this equation, right? They're not equal to one another. W, right? W is equal to z. Remember that. And w is also equal to x. Y and x are not equal to one another. So it cannot be choice number 2, right? So we're going to eliminate A, and we're going to eliminate D, and we're going to eliminate C, and we're left with choice number B, or choice letter B, right? It's telling us 1 and 3 are true, and it's going to be our answer because everything else says that 2 is true when it really isn't. And if you're confused about choice number 3, I'll explain it to you right now, right? It's saying that Z is equal to T, right? We know that T, right here, we know that T is equal to X, right? So first off, we know that X is equal to Z. So I'll write that down. I have X is equal to T. I know that X is equal to Z. And I know that W is equal to Z, right? This is saying that Z is equal to T, right? So if I know that W is equal to Z and X is equal to Z, right? Substitute Z for X, I have Z is equal to T. Perfect. That's what we were trying to prove, right? So really, all I needed was these two lines of equation. X is equal to T and X is equal to Z. That means that Z has to equal to T, right? Cut out the middleman. Like I was saying when I was doing here, T is equal to X, X is equal to Z. Cut the middleman out, you get T is equal to Z. Perfect, right? There's simply no way of like instantly proving that 2 is right, so it has to be choices 1 and 3. If you were stuck on this and you managed to prove 1 and 3, honestly, I would go out and say eliminate choice number 2 and move on, right? So moving on to number 12, it says that in the quadratic equation above, A is a non-zero constant. The graph of the equation in the xy plane is a parabola with a vertex at C, comma D. Which of the following is equal to D, right? So what this gives us is it gives us factors or it gives us zeros, right? These zeros, it's in a form such that we can easily see the zeros of the equation. The zeros are going to be 2, and the zeros are going to be 4. 2 and 4 are zeros, or that's going to be our x-intercepts. That's when y is equal to 0. It's going to pass through the point 2, and it's going to pass through the point, oh, I don't know why I wrote it like that. It's going to pass through the point negative 4, and it's going to pass through the point 2, right? It's going to go something like that. So that's an important fact. I'll get into it later. But we know that 2 and negative 4 belong here as zeros because when you plug in 2 and negative 4, it makes the whole thing 0. 2 minus 2 is 0. Negative 4 plus 4 is also 0. Anything times 0 is 0, right? Now, it's telling us that our vertex is at C, comma D. Now, the vertex of an equation of a parabola, the vertex of a parabola is always going to be in between. It's going to be the midpoint, or it's also going to be in between the x-intercepts or the zeros, right? So if I have a 0 at negative 4 and I have a 0 at 2, the x value, at least the x value of my vertex is going to be the midpoint or the halfway distance between these two. That's just a rule that's out there, right? The vertex is at the midpoint. Right? So what I'm gonna have to do is I'm gonna have to find the midpoint of 2 and negative 4. So I'm going to add those 2 points together, 2 plus negative 4. That's going to give me negative 2. And I'm going to divide negative 2 by 2, and I get negative 1, right? So the midpoint formula is just 0.1 plus 0.2 over 2. So now I know that the midpoint is negative 1 because negative 2 over 2 is negative 1. We know that the x-coordinate of our midpoint is negative 1. So C, really, our vertex happens at negative 1, comma D, right? And we know that x is negative 1, right? Our x value is negative 1. So it's asking us which of the following is equal to D. The best way we can solve for D if we have an x and we were given an equation is just plug it in, right? So here I have y is equal to a times x minus 2, so negative 1 minus 2 times negative 1 plus 4. Y is equal to a times negative 3 times 4 times 3. So y is equal to negative 9a, right? And we know that our d value is the same thing as saying our y value, so d is equal to negative 9a, right? So pretty much what we did is we noticed that this gives us our x-intercepts, right? When x is 0. We also know, and we also remembered, that the vertex is the midpoint of our zeros. So then we found the midpoint that's given to us here, right? We found the midpoint of that. Then we plugged in that midpoint because we know that the vertex, the x coordinate of the vertex is at the midpoint. We plug that into this equation, and we just simply solve for what it gave us for a y value, and that's all. So now we're moving on to number 13. It says the equation 24x squared plus 25x minus 47 over ax squared minus 2 is equal to 8x minus 3 minus 53 over ax minus 2. I had a sip of water. I feel like I've been talking extremely loud through this video. I'm sorry. But either way, it tells us that this is true for all values where x is not equal to 2 over a, right? Where a is a constant. What is the value of a? So this is really the same thing as telling me that when 24x squared plus 25x minus 47 is divided by ax minus 2, it gives us negative 8x minus 3 with the remainder of 53, right? This is an algebra 2 topic. It's like polynomial division. I think that's what it's called. But pretty much, remember that whenever you have something over something, that's the same thing as saying it's dividing. It's division, right? So for example, 4 over 2, right? That over really means 4 divided by 2, right? And that's always true for every single fraction, right? So really what this is saying is that this is the same thing as saying 4x squared plus 25x minus 47 divided by ax minus 2 is equal to so-and-so, right? So what this means is that when I do divide ax minus 2 by this by ax minus 2, I'm going to get a value that starts with negative 8. And that's what I'm going to go off here. So I'm going to write the division symbol, and I'm going to start dividing, right? So here I'm going to write my my equation, right? 24x squared plus 25x minus 47. Here I'm going to write ax minus 2, and I know that my answer is going to be negative 8x minus 3, and then I'm going to add this as my remainder, because that's just the format, right? So I already know that whatever my a is, it's going to have to go into 24x squared negative 8 times, right? So what times negative 8x is equal to 24? It has to be 3, right? A has to be minus 3. And that's it. We solved it right there. Just from the first value, we solved it. All we needed to recognize was this is a long division problem, and you just write it in the long division format, right? And here, I can prove it to you. Negative 3x, how much does negative 3x go into 24x squared, right? Well, first off, how much does negative 3 go into 24? It goes negative 8 times, because negative 3 times negative 8 is 24, right? And how many times does x go into x squared? It goes in x times, because x times x is x squared, right? And because I managed to prove it with the first value, I could just move on to the next problem, right? Because it is automatically true. So moving on to number 14, it asks us what the solutions to 3x squared plus 12x plus 6 is equal to 0. Like, what are the solutions to that, right? And that's going to be pretty easy. Now, if you don't know where to go from here, a very key giveaway is that plus minus symbol that you have here. Whenever you see that plus minus symbol and like a radical, automatically think discriminant, right? Automatically think negative b plus minus radical b squared minus 4ac over 2a, right? That's the formula. That gives us solutions. This is the formula to always find solutions. So we're just going to plug in our values, right? Remember that this is our a value, that the coefficient in front of the x squared is our a, coefficient in front of the regular x is going to be our b, and the coefficient with no x is going to be our c. So this is if we just plug in these values, it's going to be negative 12 plus minus radical 12 squared minus 4 times 3 times 6 divided by 6, right? So I'm just gonna deal with everything inside the radical, right? That's gonna be radical 144, because that's 12 squared, minus 4 times 3, which is 12. So minus 12, or negative 12, times 6, which is the same thing as saying negative 72, right? 144 minus 72 is 72, right? So here I'm going to write 72. So really, this is equal to negative 12 plus minus radical 72 divided by 6, right? Now, I'm going to have to simplify whatever is in my radical, right? Because I know that 72 can be broken down into something. Here I have radical 72. I know that that's equal to radical 36 times radical 2 because 36 times 2 is 172, right? Just slap a radical on there and it's true. Radical 36 times rad 2 is equal to radical 72. But guess what? Radical 36 perfect square. So radical 36 is really equal to 6. Now I have 6 times radical 2, which is equal to 6 rad 2. I cannot multiply them under that radical hat because this 6 lacks a radical hat, right? If this was radical 6, then that'd be radical 12. But because it lacks that cap, can't do it. So really, this is equal to negative 12 plus minus 6 rad 2 over 6. And now I could just divide both sides by 6, right? This 6 cancels out with this 6, and this 6 cancels out with this 12 to make negative 2 plus minus radical 2, which is our answer, which is A. All you have to do here, plug into that, remember how to simplify radicals, and just divide correctly. That's all you had to do. So moving on to number 15, it says the equation above shows how a temperature F measured in degrees Fahrenheit relates to temperature C measured in degrees Celsius. Based on the equation, which of the following must be true, right? And it gives us a bunch of these lists. So all I'm going to have to do here is I'm going to either have to prove them right or I'm going to have to prove them wrong. So the first one says a temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5/9 degrees Celsius. So if I look here, it's telling me that if I increase F by 1, my Celsius increases by 5/9. And I'm going to go ahead, I'm going to prove that. Say that F is equal to 32, right? If my F is equal to 32, 32 minus 32 is 0. 0 times 5/9 is 0. So when F is 32, this is the Celsius is 0. Here I have F, here I have C. Now, if I increase my F by 1, I have 33, right? 33 minus 22 is 1. 1 times 5/9 is 5/9. So here I have 33 degrees Fahrenheit, and that's equal to 5/9 degrees Celsius. Interesting. It's increasing by 5/9. I'm paranoid. What if this formula is wrong? The government is lying to me. All right, let's look at what 34 degrees Fahrenheit is. Well, if it's 34 degrees Fahrenheit, 34 minus 32 is 2, and 5/9 times 2 is 10/9, right? And now I know it's true because I have 3 points, right? This is always going to keep on increasing, right? In order for you to go from 0 to 5/9, you add by 5 nines. In order to go from 5 nines to 10/9, you have to add by 5/9, right? Because 5/9 plus 10 plus 5/9 is the same thing as saying 10/9. Your denominator stays the same, right? So I know that choice 1 is true. And from that, I can now eliminate choices B and C, right? This is a crucial thing you need to learn whenever you go through these lists. Once you know for fact that something is true, and if you have answer choices that say it's not true, immediately eliminate them, right? So B and C are wrong, not necessarily because 2 or 3 is wrong, but because they say that 1 isn't right, if that makes sense, right? My answer choice is always going to have choice 1 in it. Because I just proved that choice 1 is correct. So any choice that doesn't have choice 1, I'm going to have to eliminate. Get out of here. So now I'm left with A or B, and A says choice 1 only, and D says choice 2 only, right? So I didn't even have to prove choice 3, right? By the way, it was wrong, right? I did this beforehand. It was wrong. But just because I knew when to eliminate and what choices to eliminate, I now only have to prove choice 2 to be right. So choice 2 says a temperature increase of 1 degree Celsius is equivalent to a temperature increase of 1.8 degrees Fahrenheit. For those of you who don't know, 1.8 degrees is the same thing as saying 9/5. Okay, you could easily convert that, but so now you have to prove that. With choice number 2, it's telling us something. Rather than manipulating F here and getting C, choice number 2 is telling us that we need to manipulate C in order to get F. It's giving us F, which is Fahrenheit, in terms of Celsius, right? Here it's telling us Celsius is equal to this amount times F. Choice number 2 is telling us that Fahrenheit is equal to this amount times Celsius. It's flipped, right? So really, choice number 2 is telling us that F is equal to something increased times the amount of Celsius that you actually have, right? So I'm going to have to rewrite this in terms of F, right? Here I have C is equal to 5/9 times F minus 32, right? I need to rewrite this in terms of F, right? So in order to rewrite this in terms of F, I'm going to isolate F. So I'm going to multiply both sides by 9/5. And here I have 9/5C is equal to F minus 32. 9/5C plus 32 is equal to F, right? And off the bat, I know this is right because if we look here, an increase of 1 degree Celsius is equal to an increase of 1.8 Fahrenheit, right? For every 1 C, this gets bigger by 9 over 5, right? Here I have 9 over 5. If this is 2, this becomes 18 over 5, right? For every increase in C, this is now increasing by 9 over 5, which is 1.8. So choice number 2 has to be also true. The trick here was that maybe they thought that you would not rewrite this in terms of F, but here the variables are flipped around, right? So you need to rewrite this in terms of F to prove it true, right? So now we're gonna have to move on to the grid section, right? 5 grid questions. Now it's saying that if x is greater than 0, what is one possible solution to the equation above, right? And it's giving us all of this. So the first thing I'm going to do is I'm going to get everything on one side, and I'm going to solve for x, right? So first thing I'm going to do is I'm going to expand this. So here I have x cubed times x squared, which is equal to x to the power of 5. Remember that when you're dealing with anything with the same base, right, that's the same thing as, and if they have the same base, which is the same thing that's being raised, just add the exponents, right? So here I have x, same base, just add the exponents. 3 plus 2 is 5, right? So that's that done. And now I'm going to have to multiply negative 5 by x cubed. That's going to be negative 5x cubed. And this is going to equal to negative 4x. So here I have x 5 minus 5x cubed plus 4x is 0. Why did I add 4x? Because I wanted to get it on this side. So now what I'm going to have to do is I'm going to have to find a way to solve for x, right? And usually when you have an expression on one side equal to 0, your best bet is to factor it. So I'm going to try and I'm going to find a way to factor this out. The first thing I can do is I can factor out x, right? Because everything here has at least one x. So I'm going to factor that out. I'm going to take it out. Once I factor that x out, I'm left with x to the power of 4 minus 5x squared plus 4, right? I can't factor anything else out, right? Because there's simply nothing else that these have in common other than that x. So now that I factored that x out, right, what I have to do now is I have to figure out a way to break this x to the power of 4 minus 5x squared plus 4 into even simpler terms, right? Whenever I have something equal to 0, I'm always going to try to break it down into smaller terms in order to find my solution. So here I have x to the power of 4 minus 5x squared plus 4 is equal to 0, right? And I'm going to try to figure a way to foil this maybe and like break this down into simplest terms, right? So really, I'm looking for, I'm going to foil this, right? So I'm looking for a number or two numbers that multiply to negative 4 but add to negative 5. And those two numbers are going to be negative 1 and negative 4, right? Negative 1 times negative 4 is positive 4. So you have x to the power of 4 minus x squared minus 4x squared plus 4, right? And if you look at those two add up to, or those two subtract to negative 5x squared. A lot of people get confused when foiling. They think it only works for things that are x squared. Really, it works for a lot more than that, as long as you can find numbers that are compatible, right? So now I can break this down further, right? I can factor out x squared from this side, and I'm left with x squared minus 1. From this side, right, I can factor out negative 4, and I'm left with x squared minus 1, because negative 4 times 1 is 4. And now I could rewrite this as x squared minus 4 times x squared minus 1. Perfect. Now, of course, I could break these down to further, but really they're asking, and this times x is equal to 0, right? And this is enough to tell me one possible solution, right? I can look right here, and I can see that x squared minus 1 has to equal to 0, right? As long as one of these parentheses is equal to 0, I know a solution, right? I'm going to choose this one because this one doesn't really involve that much solving. X squared minus 1 is equal to 0. That's the same. I can take it out of the parentheses. X squared minus 1 is equal to 0. Add 1 on both sides. X squared is equal to 1. Take the square root. Square root of 1 is 1. So a possible solution is 1, right? But say you chose this part of the parentheses to solve for. Just simply set it equal to 0, right? So x squared minus 4 is equal to 0. Add 4 on both sides. X squared is equal to 4, right? X squared is equal to 4. Square root of both sides. Square root of 4 is 2, so x equal 2. So x can be 1 or x can be 2, right? Now you may be saying, oh, well, actually, there's a rule where it's like x could also technically be negative 2 because negative 2 squared is also 4. But guess what? They say that x has to be greater than 0. Which means that x cannot be 0 and x cannot be any negative number, right? So those are the only two positive numbers that you can factor this out into, right? So it sounds like a lot of work. I just didn't have that much space to work here with, but really all you had to do was just expand, factor. That's all. So now we're moving on to number 17, right? it says that if 7 over 9x minus 4 over 9x is equal to 1/4 plus 5 over 2, what's the value of x? So I'm going to rewrite this. I know that 7x over 9, I'm going to rewrite this as 7x over 9 minus 4x over 9. And then I'm going to rewrite this. Remember that since they have the same denominator, I could combine my numerators over the same denominator, right? So I'm combining the numerators, and now that I've combined the numerators, I have 7x minus 4x, right? And now, because they're both x, I can just combine like terms. I'm left with 3x over 9, or just 1/3 x, or x over 3 if I divide both sides by 3 because it simplifies. Now I have x over 3 on this side. Now I'm going to focus on this side. I have 1/4 plus 5 over 12. I want to combine this into one fraction because I combined this side into one fraction. How am I going to do that? Common denominator. Lowest common denominator is going to be 12, right? Because you can't, that's just the lowest common denominator. Don't know how else to explain it. So I'm going to have to multiply this by 3 over 3. I get 3 over 12 plus 5 over 12. I'm going to do the same thing, rewrite the numerators together. 3 plus 5 over 12. I can do this because the denominator is the same. 3 plus 5 is 8. 8 over 12 is 8 over 12, right? So here I have 8 over 12. Now I have 12x is equal to 24, right? How? Because I cross multiplied. Always remember to cross multiply when you have two fractions equal to one another. So here I have 12x is equal to 24 because 3 times 8 is 24. Divide by 12 on both sides. X has to equal to 2 because 2 times 12 is 24. So here we are. Moving on to number 18. Go ahead. I'll erase this so we have more space to work with. And first thing I'm going to notice is that the figure is not drawn to scale, right? So this isn't entirely accurate. But it's saying that two isosceles triangles are shown below. If 180 minus z is equal to 2y, and y is equal to 75, what is the value of x, right? So they give me an equation, and they give me a variable to that equation. So obviously I'm going to use it, right? Even without looking at the diagram, I'm just gonna figure out what z is, right? Here if I 180 minus z is equal to 2y, I know that y is 75, so 180 minus z is equal to 2 times 75, and 75 times 2 is 150. So here I have 150. So z has to equal to 30, because 30 minus 180 is 150, right? So now that I know that z is 30, I could write that over here. Now I know that this is an isosceles triangle, right? Not only does it tell us this, but there's these two symbols on the lines. That means that this side is equal to this side. An isosceles triangle is a triangle that has two sides that are equal to one another. And another property of an isosceles triangle is that there's at least two angles that are going to be equal to one another. So this angle is going to be equal to this angle. That's just how an isosceles triangle works. This angle is not going to be equal to that angle. So two angles are going to have the same measure, and one angle is going to have a different measure. Z is going to have a different measure, but these two angles, which are opposite the equal signs, are going to have the same measure. So really, what we could write this as is we could write this as 30 plus 2a, where a is the measure of these angles inside, is equal to 180. Remember that the total sum of degrees inside a triangle is equal to 180. So I have 2a is equal to 150. Divide by 2, a is equal to 75, right? Because we just did that here. So we know that the measure of these two angles is 75 and 75, right? And that all equals up to 180. So really they're asking us for x. And that's a big thing. If I know that this is 75, I know that 75 plus x is equal to what? Well, if I add 75 to x, really I get 180. Why? Because I get a straight line, right? 75 plus x represents this distance, right? This whole degree measure. And that's a straight line. Straight line is always equal to 180 degrees. So 75 plus x is equal to 180. Subtract 75 from both sides. And that means that x has to equal to 105 degrees. All right. So moving on to number 19, it says, at a lunch stand, each hamburger has 50 more calories than an order of fries. Okay, so we know that the amount of calories in a hamburger is equal to the amount of calories in a French fry, or an order of French fries, plus 50 calories, right? Now they tell us if two hamburgers, so 2h, plus 3 fries have a total of 1,700 calories, how many calories does a hamburger have? So if we already know what h is, how about we just substitute this into the h? So really I have 2 times f plus 50 plus 3f is equal to 1,700, right? Now I could just expand this. I have 2f plus 100 is equal to plus 3f is equal to 1,700. So I have 5f plus 100 is equal to 1,700. Subtract 100 on both sides. I have 5f is equal to 1,600. And here I can divide the 1,600 by 5. which is my next step, by the way. So that's going to be 3, 15. That's going to be 0, 1, 2, 0. So the number of calories in a French fry, or an order of French fries, is 320. But remember, they're asking us how many calories a hamburger have, right? That's the key word. So we can't put 320. We have to solve for the hamburger. We know that hamburger is fries plus 50, right? And if we know that there's 320 calories in an order of fries, that's going to be 320 plus 50. And that means that h has to equal to 370. That's our answer. Last question, number 20. It says, in a triangle ABC, the measure of angle B is 90. So I'm going to go ahead, I'm going to write that, or I'm going to draw that right here. So doesn't matter what's A, doesn't matter what's C. All we know, all that matters is that B is 90, right? I'm just going to write AC right there, right? Next, it's saying that BC is equal to 16 and AC is equal to 20. Now it's saying that triangle DEF is similar to ABC, where vertices DEF correspond to vertices ABC respectively. Whenever you see respectively, that means that like the two lists correspond, right? So D corresponds with A because they said respectively the first thing of this list has to correspond with the first thing of that list. So I'm gonna go ahead, I'm gonna draw this similar triangle out over here, right? D corresponds with A, so here that where D is, A has to be, where B is, E has to be, and where F is, that just has to be there, right? So here we have this, right? And we know that each side of triangle DEF is a third the length of the corresponding side of ABC, and it's asking us for the sine of F, right? So a cool thing to know is that the whenever you have similar triangles, right, and it's asking you for the sine of the angle of one similar triangle, it's going to be the same thing, right? So the sine of F is going to equal to the sine of C, right? So if you're asking me for the sine of F, that's the same thing as asking me for the sine of C, because the ratio, right? Remember, trigonometry is all about ratios. The ratios between the similar triangles are always going to be the same, right? So really, sine F and sine C are the same thing, right? We know that sine is equal to opposite over hypotenuse, right? So it's really going to be AB over AC, right? We know AC is 20, but we don't know what AB is. We know this is a right triangle, so we can use Pythagorean theorem. A squared plus B squared is equal to C squared. So A squared, which is going to be this, plus B squared, which is 16 squared, is going to equal to 20 squared, right? So A squared plus 16 times 16, let's figure that out. 6, 3, 9, 0, 6, 1, 6, 5, 256 is equal to 20 squared, which is 400. 400 minus 256 is equal to 3, 9, 10, 4, 4, 1. So that means that A squared is equal to 144, right? Take the square root on both sides. A is equal to 12, so we know that A is equal to 12. I just said it. I don't know why I repeated myself, but here we have 12. Now, remember, sine is equal to opposite over hypotenuse, right? So here opposite is 12, hypotenuse is 20, so 12 over 20. If we try to grid this in, we don't have enough space, so that means we have to simplify it. If we divide both sides by 4, we get 3 over 5, and that's going to be our answer, right? And if you're still unsure, if you think I'm lying to you about the sine or any trigonometry function being a ratio, like sine, cosine, tan, they're all ratios, right? So if you have the sine of two similar triangles, that sine is going to be the same thing. If you don't trust me, let's check it out right here. If we know that DEF is a third of the length of the corresponding triangle ABC, right? So DEF is always going to be a third of the length of ABC. So a third of 12 is going to be 4, and a third of 20 is going to be 20 over 3, right? And remember, opposite over hypotenuse, right? So here we're going to have opposite, which is 4 over 1, divided by 20 over 3. Same thing as saying 3 times 20, which is 12 over 20. And guess what? Hey, same thing, baby. And then they both simplify into 3 over 5. I just think that the problem works itself out to be a little bit faster if you just solve directly through triangle ABC rather than dividing everything by 3 and moving on to DEF. But that's all 20 questions from section 3. No calculator section. If you want to follow along or try this test out for yourself, the link to it will be in my description, alongside the answers, and the scoring sheet will also be in the link of my description. If you have any questions, please feel free to put them down in the comments. If you like the video, like it, and if you want more SAT videos, let me know, and the best way you can is by subscribing. So